Welcome to a video on RAID levels, and welcome to my channel Free Technology Net. RAID is redundant array of independent disks or redundant array of inexpensive disks. It is a hardware equipment equipped with multiple data disks slotted into, and status lit with LEDs. RAID is a data storage technology. It combines physical data storage into one or more logical units, used for data read-write performance, data redundancy, or both performance and redundancy, and also for data storage expansion. It is an innovation to previous concept of SLED, which was meant as single large expensive disk. The term RAID was invented by David Patterson, Garth Gibson, and Randy Katz at the University of California, Berkeley in 1987. The top-performing mainframe disk drives of the time could be beaten on performance by an array of the inexpensive drives that had been developed for the growing personal computer market. To know the working of RAID, we should know how the data is write and read to from the disk storage. The data is signified by systems as data block. A data block refers to a collection of bytes of data grouped together. Traditionally, a block was 512 bytes in older storage systems, but the more commonly accepted block size today is 4 kilobytes. For example, if you have a picture that is 128 kilobytes in size, it will be saved across 32 blocks of 4 kilobytes each. The block size determines the maximum size of read or write requests that a file system can send to the I/O device driver. A block, sometimes called a physical record, is a sequence of bytes or bits, usually containing some whole number of records, having a maximum length, a block size. Data thus structured are said to be blocked. The process of putting data into blocks is called blocking, while deblocking is the process of extracting data from blocks. RAID, redundant array of independent disks, is a way of storing the same data in different places on multiple hard disks or SSDs to protect data in the case of a drive failure. There are different RAID levels, however, and not all have the goal of providing redundancy. RAID 0, disk striping, is the process of spreading the data blocks across multiple storage devices. It is a way of arranging multiple storage devices so they can work together as a single device in order to host a single volume. RAID 0 is known as a stripe set, with data divided across the set of drives. A striped unit refers to the data slice that resides on an individual drive. RAID 1, mirroring is achieved with the utilization of minimum 2 drives, for which only 50% of storage space can only be utilized. RAID 1 is only used for redundancy, and not for performance. The disks in a single RAID 1 volume is called as an array. It duplicates data from one drive to another. The RAID 1 mirroring also has the benefit of providing high availability and rapid recovery but cannot match the speedy reads and writes of RAID 0. In RAID 0, 100% of overall disk space can be utilized, but RAID 1 provides only 50% disk utilization. RAID 5, striping with parity is achieved with the utilization of minimum 3 drives, for which only N1 amount of storage space can be utilized. RAID 5 is used for both performance and redundancy. Like RAID 1, it doesn't duplicate any data, but it consumes a single disk space as parity of data. The RAID 5 has both the benefit of providing recovery and speed performance than RAID 1. In RAID 5, N1 amount of overall disk spaces in the array can be utilized, compared to 50% disk utilization of RAID 1. Here comes the list of standard RAID levels denoting RAID 0 to RAID 6, nested or combined RAID levels such as RAID 01, 03, 10, 50, 60, and 100. Both the standard and nested RAID levels are featured for the performance, fault tolerance, or for both. Non-standard RAID level feature for expansion of a single storage volume to a larger extent by expanding a single storage volume to multiple disks. Here as illustrated, RAID 0, the data will be striped block-wise across 2 or more disks, for increased performance and added storage volume. For RAID 1, the data will be mirrored to another disk, for fault tolerance in case of a drive failure. RAID 2, in fact it is less implemented or not at all, for which the fault tolerance is achieved with Hamming code operation along with bit-level striping. For RAID 3, the data is striped as bytes with a single disk will be dedicated for parity, for which fault tolerance is achieved, but less performance than RAID 5. RAID 4, the data will be striped as blockwise with single dedicated disk for parity, the fault tolerance is achieved, and less performance than RAID 5. In RAID 5, the data will be striped blockwise across 3 or more drives, for which the data will be written randomly across the drives along with a single parity. Here fault tolerance is achieved along with performance. In RAID 6, the data will be striped blockwise across 4 or more drives. The data will be written randomly across the drives along with 2 parity blocks. Here fault tolerance is achieved for double disk failure, along with performance. Nested RAIDs, as the name denotes, it is a combination of multiple RAID levels or arrays, to achieve more performance along with redundancy. RAID 01, as illustrated, it requires a minimum of 4 disks, with 2 RAID 0 arrays, and 1 combined RAID 1 array. Here the data blocks written to volume will be mirrored between 2 RAID 0 arrays. Each RAID 0 array data will be striped across for performance and drive spaces. In RAID 01, the storage volume utilization is only 50%. RAID 03 requires a minimum of 6 disks, with 3 RAID 0 arrays, and 1 combined RAID 3 array. Here the data bytes written to volume will be striped to 2 RAID 0 arrays along with single parity to third dedicated RAID 0 array. In RAID 03, the storage volume utilization is 66% and more. RAID 10 requires a minimum of 4 disks, same as RAID 01. There will be 2 RAID 1 arrays, and 1 combined RAID 0 array. Here the data blocks written to volume will be striped between 2 RAID 1 arrays, and each RAID 1 arrays mirrors the data. In RAID 10 also, the storage volume utilization is 50%. RAID 10 is more advantageous than RAID 01 for performance and RAID stability. RAID 50 requires a minimum of 6 disks, with 2 RAID 5 arrays, and a combined RAID 0 array. Here the data blocks written to volume will be striped across 2 RAID 5 arrays, and each RAID 5 array block will be striped across along with parity for fault tolerance. In RAID 50, the storage volume utilization is 66% and more. RAID 60 requires a minimum of 8 disks, with 2 RAID 6 arrays, a combined RAID 0 array. Here the data blocks written to volume will be striped across 2 RAID 6 arrays, and each RAID 6 array block will be striped across 2 parities for double fault tolerance. In RAID 60, the storage volume utilization is 50% and more. RAID 100 also requires a minimum of 8 disks, with 4 RAID 1 arrays, 2 combined RAID 0 arrays with 2 set of RAID 1 arrays, and a single combined RAID 0 array with 2 combined RAID 0 arrays. In RAID 100, the storage utilization is only 50%. Sure. Here's a comparison of the standard RAID, redundant array of independent disks, levels commonly used in storage systems. Each has its own balance of performance, redundancy, and storage efficiency. Quick breakdown. RAID 0, fastest, but no protection. 1 drive fails equals total data loss. RAID 1, redundant, but expensive, only 50% usable storage. RAID 5, great for general purpose use, most common in small to mid-sized businesses. RAID 6, adds extra redundancy, great for larger arrays. Here you can find a short comparison on nested RAID levels. RAID 01 requires minimum 4 disks, and space utilization is 50% or less. RAID 03 require minimum 6 disks, and space utilization is 66% and more. RAID 10 require a minimum of 4 disks, with space utilization of 50% or less. RAID 1 plus 6 require 8 disks minimum, and only 25% or less only space will be utilized. Here find more nested RAID levels. RAID 50 with minimum 6 drives, and utilization of 66% or more. RAID 60 with minimum 8 drives, and utilization of 50% or more. RAID 100 with minimum of 8 disks, and only 50% or less can be utilized. JBOD, which stands for just a bunch of disks, is a type of multilevel configuration for disks. It refers to a collection of disks in a computer system or array combined as one logical volume. It offers huge amounts of storage and can be configured depending on the user's needs. JBOD is the opposite of disk partitioning, for which individual drives are segmented into smaller volumes, as JBOD combines drives into larger unit volumes. RAID can implemented or executed with 3 type setups: hardware, software, and firmware. Note that in all the cases, the storage medium are more or same the disk drives, only the execution type differs. A hardware RAID is basically a form of a RAID in which all the processing is done on the motherboard. It is a method where each of the drives are connected to a hardware RAID controller, which is basically on a separate RAID card, different server, or built into a motherboard. The multiple RAID arrays are supported and configured by the hardware RAID controllers. The RAID controller can act as a mini version of a computer, as they do come with processors to carry out the tasks. There is no additional load on the server processor since the RAID is managed by and processed on the controller board. Hardware RAID is much faster than software RAID, and is much compatible across different operating systems. Because it is handled by a dedicated RAID system, it gives very little stress to system. The hardware RAID system is protected from viruses. It offers flexibility, and offers more configurations than software RAID. It can protect from data loss and data corruption since RAID cards are equipped with backup batteries. Software RAID is a storage technology that organizes multiple physical drives into a single array using software rather than dedicated hardware. It enhances speed, storage capacity, and data safety by relying on the host system's CPU and memory for RAID operations. Software RAID is more affordable because it utilizes existing system resources instead of specialized hardware. It is hardware independent, works with networked and other attached storages. Its disadvantages includes, it is operation system specific, uses host resources such as CPU and RAM, which leads to less performance compared to hardware-based. Xi-RAID is a software RAID engine specifically designed to handle the high level of parallelism in NVMe SSDs. Its innovative data path exploits the full potential of NVMe drives while offering superior resiliency. Zinner develops 11-RAID, and presently compatible with Linux environments. It can connect directly attached drives and also drives connected by NVMe over fabrics. Software-implemented RAID is not always compatible with the system's boot process. However, hardware RAID controllers are expensive and proprietary. To fill this gap, inexpensive RAID controllers were introduced that do not contain a dedicated RAID controller chip, but simply a standard drive controller chip, or the chipset built-in RAID function, with proprietary firmware and drivers. During early bootup, the RAID is implemented by the firmware and, once the operating system has been more completely loaded, the drivers take over control. It requires the driver support for the host operating system to boot up and function. Example is Intel Rapid Storage Technology. If you have any queries, do drop an email at info@freetechnology.net or do comment us. Also, for more videos, please subscribe to our channel.